This is our 4th semester control applications project. This here is the bottom side of it. As you can see, there are several pieces of aluminum frame held together by these brackets running across a 4x8 sheet of plywood. Underneath the plywood here you can see we have screws in several areas that's holding our track to the plywood. We have got a box section right here in the middle that fits underneath the rolling cart. That is the base. And if you come around this side, you can see our proximity sensor wires running through to go to the track side. And then over here, they are running through to go into the PLC box. We have our hole cut here for our power wire to run through. And then we've got several brackets and lots of bracing, because with an 8-foot chunk like this, it would tend to torque from side to side when you were lifting it. And then down here is the plexiglass barrier, which you'll see better when it's flipped upright. And this here is the rolling cart that it sets onto, and it's not secured to this, so then it's somewhat portable. You can slide this into the back of an SUV, and we put these little angled pieces on here to make it more like a ski so it wouldn't rip the carpet in the back of the vehicle. And later on in the video, we will show you the top side of the track and explain to you why there are proximity sensors on a racetrack. Right, this is our Ninco slot track set for our 4th semester control applications class. We had built this aluminum frame ourselves, slapped it on a piece of 4x8 plywood. We have a plexiglass barrier all the way around, and the aluminum frame is held together by these brackets. It's a 80/20 frame. Now what you'll notice different about this here track is there are proximity sensors in and out of all 4 corners. Now those work for the inside track. This inside track is going to be a car that's controlled by a PLC. We'll control the voltage in the straightaways to about 12 volts, and we slow it down into the corner somewhere around 8 to 9 volts, and then out of the corner back to 12, and then back to the 8 or 9 for that corner, and so on for 5 laps until you can see who won. The other track will still be ran by a human operator with a 60 ohm resistor and the handheld controller. And even though our track is shorter, we give them enough voltage to see if they can try to beat the response time of the proximity sensors. This track has a stack light to represent the tree for a race. It's got a clip to hold it down for transportation. And if you stand it up, it's quite large and it makes the track very noticeable at a distance. Have several decals on the background on the barrier. The cars did like to fly off quite a bit, so we did have to build the surround. Now what we have here is, on the back side of this, we'll be plugging in the controller 3.5mm plug, but instead of using the power outlets on the back, we're going to run the power straight through the 3.5mm plug, just running a positive and negative to each track, which will power the car and which will allow us to manipulate the voltage via PLC. Then all these here are the quick disconnects for the proximity sensors, and they will plug into the box which the PLC is located in. And then this is the quick disconnect for our stack light. In a later video, we will show the internal wiring of the PLC box, and then we'll show a brief description of how the cars actually operate around this track. Thank you. Alright, here we have a side profile of our racetrack plywood platform sitting on top of the rolling cart. If you get up here closer, you can see all of these bolts across the inside. Those are there to hold the plywood to the lower 80/20 frame that we showed in a previous video. And then the screw holes that I showed on the other side, they are here holding the track down. And now this track, when you flip it over, it actually has spots where it can have holes put in it. So we just went through and drilled those out. We countersunk the top of the track, so then that way our screws would sit flushly so the tires wouldn't hit them and throw the cars off of the track. And we do have the plywood set up into thirds here. If you see, there's a strip running there and a strip running there. Hopefully in a later project where each one of these sections are, this will actually break apart and fold down. We have the three sections of plexi, which would be, a third of each. Then the plywood is into thirds, and the thirds actually line up right across the split in the track here. So then this section would be one piece. The center section with all the wiring would be another piece. And then the final section would just be this tail end over here, and it would either fold down around the cart or it would fold up onto itself, and that would also help make it a little more portable and maybe fit in a smaller vehicle than the SUV that we had been planning on. Thank you. I just want a little video. Yeah, a little action.